Frequency is the number of complete cycles that occur in a 1-second time frame. A cycle is 360 degrees. This picture shows an example of one complete cycle. This is a picture of two wavelengths. The top wavelength has a much greater frequency than the bottom. If you count the number of complete cycles, which is 360 degrees, you will see that on the top there are more cycles than on the bottom. Thus, the frequency of the top wavelength is greater. Wavelength represents the distance of one complete cycle of vibration. Wavelength can be measured starting anywhere in the cycle. For this picture, it starts at the first peak of compression, goes 360 degrees to the second peak of compression. The amount of distance needed for this cycle to occur is what we refer to as wavelength. Wavelength and frequency have an inverse relationship. Assume that when the basketball gets in the basket, one complete cycle has occurred. Now, let's see the relationship between wavelength and frequency. For explanation purposes, let's pretend this is a clip of a 1-second time frame. He is standing close to the basket, which means the wavelength is short. The ball does not have to travel a far distance in order to complete a cycle. Since the wavelength is short, in this 1-second time frame, 9 cycles were completed. So, when the wavelength is short, the frequency, which is the number of cycles per 1 second, is high. Let's see what happens to the frequency when the wavelength gets longer. Let's pretend this clip is also a 1-second time frame. Now, he is standing further away from the basket, so the wavelength is longer. The ball has to travel a further distance in order to complete a cycle. So, in this same 1-second time period, there were only 4 cycles completed. Since the wavelength increased, the frequency decreased. This image depicts the overall inverse relationship between wavelength and frequency.